In this video, we're going to go through a CFA Level 1 style question on the steps you need to take when asked to compute the weighted average cost of capital, or WACC, from various funding sources. Although WACC itself is covered within the corporate issuers topic area, the solution which I'm going to present requires some appreciation of topics covered in other sections of the curriculum. More specifically, equity investments and fixed income. So if this is something you want to get right in the exam, keep watching and let's get solving. So this is the question that I want you to have a go at. An analyst gathers the following data about a company. The company's tax rate is 20%. The company plans to maintain a capital structure consisting of 65% ordinary shares, 15% preferred shares and 20% debt. The company's ordinary shares are trading at €56 per share. The shares are expected to pay a €4.5 dividend 1 year from today, which is expected to grow at a constant rate of 5%. The company's 6% preferred stock is currently trading at 98 per 100 of par value. The company's 10-year, 3.5% annual pay coupon bonds are trading at 101.3 per 100 of par value. The company's weighted average cost of capital is closest to A, 9%, B, 9.9%, or C, 10.8%. Okay, so what we need to do is take each source of capital and compute its cost for the company, and subsequently compute a weighted average cost of capital, taking into account the proportions in which these sources feature in the company's overall capital structure. Let's start with ordinary shares. Here, everything points to the need to use the Gordon constant growth model. You should know this from your studies of equity investments, and I have also covered this model pretty extensively in past videos. So the price of a stock today, P0, so the price at time 0, equals D1, the dividend forecast 1 year from today, divided by R minus G, where R is the rate of return required by equity investors and G is the constant rate of dividend growth. The number we are actually looking for is the R over here, and this is because the rate of return required by ordinary shareholders is also the cost to the company of using equity capital. Let's just transform this fraction a little. So R minus G equals D1 over P0. And now let's just transfer the term G to the right-hand side. So that leaves us with R equal to D1 over P0 plus G. Checking the question for the relevant data. The company's ordinary shares are trading at €56 per share. The shares are expected to pay a €4.5 dividend 1 year from today, which is expected to grow at a constant rate of 5%. So we get 4.5 for D1 over 56, the share price today, plus a growth rate of 5% or 0.05. Let's do this on the calculator. So we've got 4.5 divided by 56 plus 0.05, and that gives me a result of roughly 13% if we round it up to down to 1 decimal mark. 13.0%. And that's the cost of ordinary shares. Now I'm going to draw a line here and let's move on to the next source of capital. And the next source is going to be preferred stock or preferred shares. The idea behind these shares is that they pay a constant dividend which does not grow over time. And we can easily treat this as being synonymous with a growth rate of 0. So we end up with the following formula. Just like before, I'm going to express this as P0 equal to D1, or just D, the constant dividend. It doesn't have to be D1 because D0, D1, D2 is going to be the same thing, over R, the rate of return required by preferred stockholders. I don't have minus G because G, I'm going to assume, is 0. This dividend doesn't grow. Okay, now to get R on the left-hand side, I need to do a little bit of transformation. So R equals D divided by P0. Let's check the scenario. The company's 6% preferred stock is currently trading at 98 per 100 of par value. So the dividend rate is set at a constant 6% of 100, i.e. 6, and the share price is 98. So let me write this down, 6 over 98. And if we do this on the calculator, 6 divided by 98 gives a result of roughly 6.1%. And this is the cost of preferred stock. And finally, we need to compute the rate of return required by the providers of debt. And this is synonymous with computing the yield to maturity on the company's bonds. And in order to do this, you need to use the TVM worksheet on your calculators. So let's just remind ourselves of what the inputs should be. The company's 10-year, 3.5% annual pay coupon bonds are trading at 101.3 per 100 of par value. Always remember to clear the TVM worksheet first. So we do this by pressing second followed by FV, where FV has the secondary function clear TVM. And now we are ready for the actual inputs. So it doesn't matter what order you actually provide that in, or these inputs in. I'm going to start with N. That's going to be the number of periods. Now, N is going to be set at 10, seeing as the bonds are 10-year bonds. So what I need to do is press 10, or input 10 followed by the N key. So 10 followed by N. Next, I'm going to provide the calculator with the value of the bonds today. So that's their present value. And we read that the bonds are trading at 101.3. So 101.3 followed by the plus minus key, because I want to make this a negative input, seeing as we are paying, or investors are paying for these bonds. That's a negative cash flow. And next, the PV key on that third row of keys from the top on your calculators, where we've got the time value of money worksheet. Okay, that's set, and that's input. The calculator has accepted this as the input for PV. The next thing I can tell the calculator is that the future value, meaning when the bonds mature in 10 years' time, is going to be 100. So 100 followed by FV. That's the third input. And I also want to tell the calculator what the coupon is. Well, the coupon here was 3.5%. So 3.5 followed by PMT. And please note that this 3.5 as well as the 100, both of these inputs were positive, seeing as from an investor's point of view, this is something that investors receive for a bond, from the bond, for which they paid a certain amount. Now, we've made all the inputs that we could. Let's now get the calculator to compute the yield to maturity, and we do this by pressing the CPT key, which is sitting at the very top of your calculator keys on the left-hand side, followed by I over Y, which stands for yield. And you can see that this comes in at roughly 3.3%. Okay, on to the actual weighted average cost of capital computation. Here we will need to use the proper weights. And let's go back to the scenario one more time to find these. The company plans to maintain a capital structure consisting of 65% ordinary shares, 15% preferred shares, and 20% debt. We will also, in just a moment, need the company's marginal tax rate, which is given as 20%. So what I could do is write that WACC equals 0.65 to reflect 65% weight for the company's ordinary shares times the cost of equity, i.e. the cost of ordinary shares, plus whatever was the weight for the preferred shares, that was 15%, 0.15, times the cost of preferred shares, which we had over here. And I'm also going to have my final source of capital, that was debt. Its weight was 20%, so 0.20 times the cost of debt, which we actually computed over here, but critically multiplied by 1 minus t, the tax shield, to account for the fact that interest paid on debt is tax deductible. Now, let's put in the additional numbers over here. So I've got 0.65 times the cost of equity, 13%, plus 0.15 times the cost of preferred shares, that was 6.1%, and 0.20 times the cost of debt, 3.3%, but multiplied by 1 minus the tax rate. Well, the tax rate provided in the question was 20%, so 1 minus that is 0.8. And I can now take my calculator and do this computation. Let's hope I don't make any mistakes inputting the numbers. So 0.65 times 13 plus 0.15 times 6.1 plus 0.2 times 3.3, but multiplied by 0.8. Okay, I am looking at a figure equal to 9.9%. So, as we can easily see, checking the possible solutions to this question, this actually corresponds to answer B.